Welcome to my YouTube channel Cognara. I'm Michael, your science and technology educator. Today, we are going to explore an idea that feels simple at first, yet becomes deeply unsettling the longer you sit with it. It is an idea that challenges one of the most basic assumptions of everyday life. The assumption that time flows smoothly, steadily, and the same for everyone. What if that assumption is wrong? What if time, as we experience it, is not a fundamental feature of the universe at all? What if time can slow down, stretch, fragment, or even break down completely under certain conditions? This is not philosophy alone. It is a question modern physics is actively struggling with. And the answers are far stranger than most people realize. For most of human history, time felt absolute. The sun rose and set. Seasons came and went. Clocks ticked forward in neat, predictable steps. Time seemed like a universal background, moving forward at the same pace for everyone, everywhere. Even Isaac Newton believed time flowed uniformly, independent of anything else. According to this view, time existed on its own, like an invisible river carrying the universe along. Then, in the early 20th century, that idea quietly collapsed. Albert Einstein showed that time is not fixed. It stretches and slows depending on speed and gravity. Two clocks moving differently, or sitting in different gravitational fields, will not agree on how much time has passed. This was not just theory. It has been tested again and again. Clocks on satellites tick slightly faster than clocks on Earth. Without correcting for this effect, modern GPS systems would fail within minutes. Time, it turns out, is flexible. But this was only the beginning. As physics advanced, scientists began asking a deeper question. If time can stretch and slow, what exactly is it? Is time something real and fundamental, or is it an effect that emerges from deeper processes? To explore this, physicists turned to the smallest scales of reality, where quantum mechanics rules. Here, time behaves very differently. At the quantum level, particles do not follow smooth trajectories through time. Instead, they exist as probabilities. Events do not happen in a clear sequence. Cause and effect blur. In some experiments, it becomes impossible to say which event happened first. This creates a serious problem. Our most successful theories of physics do not agree on what time is. General relativity treats time as part of the fabric of spacetime, shaped by mass and energy. Quantum mechanics, on the other hand, often treats time as an external parameter, something assumed rather than explained. When scientists try to combine these theories into a theory of quantum gravity, time begins to disappear from the equations altogether. This is not a metaphor. In several leading approaches to quantum gravity, the fundamental equations contain no time variable at all. The universe is described as a static structure. Nothing evolves. Nothing flows. And yet, we experience time constantly. This contradiction lies at the heart of modern physics. One way to understand this is to imagine a book. From the outside, the entire story exists at once. Every page, every chapter, every event is already there. Nothing in the book changes. It simply exists as a complete object. But when you read the book, you experience it page by page. The story unfolds. Characters change. Events seem to happen over time. Some physicists believe the universe may be similar. From a fundamental perspective, the universe may be timeless. past, present, and future may all coexist as part of a single structure. What we experience as the flow of time could be the way consciousness moves through that structure. This idea is often called the block universe. In this view, time does not pass. We pass through time. At first, this idea feels deeply uncomfortable. It seems to deny free will and the reality of change. But physics does not ask what feels comfortable. It asks what fits the evidence. And the evidence increasingly suggests that time behaves more like an emergent phenomenon than a basic ingredient of reality. Consider entropy. Entropy is a measure of disorder. The second law of thermodynamics tells us that entropy tends to increase. This gives time its arrow. We remember the past, not the future. Eggs break, but do not unbreak. Heat flows from hot to cold. Many physicists now believe that the flow of time we experience comes from entropy, not from time itself. In other words, time feels like it moves forward because the universe is becoming more disordered. If entropy were reversed, time would feel reversed too. This raises a startling possibility. Without entropy, time might lose its direction altogether. Now consider black holes. Black holes push our understanding of time to its limits. Near a black hole, time slows dramatically relative to distant observers. At the event horizon, time appears to stop entirely, at least from the outside perspective. Inside a black hole, our equations break down. Space and time swap roles. What we call the future becomes unavoidable, like falling forward in time rather than space. Some theories suggest that inside black holes, time may fragment or lose meaning altogether. If time can behave so differently in extreme environments, it raises a profound question. Is time universal, or is it local? Does time exist everywhere in the same way, or only where conditions allow it to emerge? Recent experiments are adding new layers to this mystery. In certain quantum experiments, particles appear to exist in states where the order of events is not fixed. One event does not clearly happen before or after another. Instead, both orders coexist. This phenomenon is sometimes called indefinite causal order. In these experiments, the universe does not seem to care about sequence. If cause and effect are not fixed at the quantum level, then time, as a strict ordering of events, may not be fundamental. It may be something that only emerges when many particles interact in complex systems, like brains, clocks, and planets. This brings us to a deeply human question. If time is not fundamental, what does that mean for our experience of living? Our lives are structured around time. We plan, remember, anticipate, and regret. We define ourselves through past experiences and future goals. Yet physics suggests that this familiar flow may be a kind of illusion. Not a fake illusion, but an emergent one. A useful pattern that appears when complexity reaches a certain threshold. Just as temperature emerges from the motion of many particles, time may emerge from the behavior of complex systems. At the most basic level, there may be no ticking clock. Some scientists are exploring whether time itself could break down under certain conditions. Near the beginning of the universe, during the earliest moments after the Big Bang, time may not have existed in any meaningful way. The laws of physics as we know them may not apply. Asking what happened before that moment may be meaningless, because there was no time for things to happen in. In this view, time began when the universe cooled enough for stable structures to form. Time did not exist first. The universe created time. This idea reshapes how we think about the future as well. If time is emergent, then in extreme situations, such as inside black holes or near singularities, time could break down again. The universe may contain regions where the concept of before and after simply does not apply. This is not science fiction. These are serious questions being explored by theoretical physicists today. And they matter because time is not just a background. It is woven into every physical law we use. If our understanding of time is incomplete, then our understanding of reality itself is incomplete. There is also a deeper philosophical implication. If past, present, and future all coexist in some fundamental sense, then the universe is far less dynamic than it appears. Change may be a feature of perspective, not reality. This does not mean your experiences are unreal. Pain, joy, love, and choice are real because they are experienced. But their place in time may be fixed within a larger structure. From this perspective, the universe is not a process unfolding. It is a pattern already complete. We experience it one moment at a time. Some people find this idea unsettling. Others find it comforting. If the universe is timeless at its core, then nothing is ever truly lost. Every moment exists forever as part of the structure of reality. Every conversation, every sunrise, every decision remains embedded in the fabric of the universe. Time does not erase them. It simply moves our awareness forward. At the same time, physics remains cautious. No single experiment has proven that time is an illusion. Many theories remain speculative. New data may change everything again. Science is not declaring that time does not exist. It is questioning whether time is as fundamental as we once believed. And that distinction matters. We are living in a moment where one of the deepest assumptions of human experience is under serious scientific scrutiny. Clocks still tick. Days still pass. Life still unfolds. But beneath the familiar surface, physics is revealing a universe where time is flexible, fragile, and possibly emergent. The day time breaks down may not be a dramatic event. It may already be happening quietly, in equations, experiments, and observations that challenge our intuition. And as always, the universe is reminding us of something important. Reality is under no obligation to match how it feels. Thank you for taking this thoughtful journey with me today. If you enjoy calm, reflective explorations of science and the deeper nature of reality, you are exactly where you belong here at Cognara.